Okay, question, constructing a box of maximum volume. So this is an optimization question. So a square sheet of cardboard. So we have a square sheet of cardboard and the cardboard is 18 inches on a side. And then it says it's made into an open box. So what we need to do is to cut out the corners. So the corners we're going to call X. So then the length of our box is actually going to be 18 minus 2x. So on the other side, 18 minus 2x also. And we need to find the maximum volume. So we're going to turn our box or our paper. That's very good. Let's do it again. So we're going to turn our paper into a square box. And we'll have 18 minus 2x by 18 minus 2x. And the volume, the height we need is going to be x. So the volume of our box is x multiplied by 18 minus 2x squared. Now we can factor this. So if we factor, we will have 4x 9 minus x squared. So this is our equation for our volume. Now we need to take the first derivative so we can calculate the critical points. So if we take the first derivative of x, we will have to use, because we have two terms, so we're going to use the product rule and the chain rule. So the product rule says that the f prime multiplied by g of x plus f of x multiplied by g prime of x. And the chain rule, we need to use this for g of x. So this is going to be that we take our power, we multiply it, so we're going to write it in front, so our chain rule, so we'll have 2 multiplied by, the inside term stays the same, but we minus 1 from the powers, or exponent, so this will be 1, and then we multiply that by the derivative of the inside, which is going to be negative 1. So this is our g prime of x. So let's substitute this in. So f prime, so f of x is 4x, so f prime is 4. Multiplied by g of x, so g of x is going to be 9 minus x squared. Plus, so our f of x is 4x. And then our g prime of x, using the chain rule, we have minus 2, 9 minus x. So minus 2 and 9 minus x. So now, if we look, we have common factors. So I'm going to factor by 9 minus x. So if I factor by 9 minus x, I will have 4, 9 minus x, because we still have 1 there, plus 4x multiplied by minus 2. So 9 minus x, and then we're going to multiply out these brackets. So we have 36 minus 4x minus 8x. So simplifying, so minus 4 minus 8. So this is going to be 36 minus 12x. And we're going to look at simplifying by factoring here. So 9 minus x, I'm going to factor by 12. So bring in 12, we'll have 3 minus x. So I'm just going to write 12 in front. So 12, 9 minus x, 3 minus x. So now if we set this to 0, 9 minus x equals 0, or 3 minus x is 0. So x is equal to 9, or x is equal to 3. Okay, so I'm going to look at our equation for volume. So we said 4x, 9 minus x squared. So if I was to take one of those equations, so 4x equals 0, so x is 0, is equal to 9. So this is our domain. So we're expecting our values to be between 0 and 9. So what I'm going to do is substitute to find the values. So when the x is equal to 0, we're going to find the volume. So when x is equal to 0, our volume, so we substitute in 0 and we'll have our volume will be 0. If we substitute in 3, so our volume, 4 multiplied by 3 multiplied by 9 minus 3 squared. So 12 multiplied by 6 squared, which is 36. So we'll have 432. So when x is 3, we'll have a volume of 432. And then when x is 9, the volume will be 4 multiplied by 9. 9 minus 9 squared. So 36 multiplied by 0. So the volume will be 0. When x is 3, we will have the maximum volume. So the solution is when x is 3 inches, the maximum volume 432 cubic inches. Okay, so we could check this in Desmos. Okay, so if we put this into Desmos, so our equation that we had for volume, so y is equal to 4x multiplied by 9 minus x squared. Now, we can't see this graph very well. It's a bit big. So I'm going to go to settings and I'm going to change my axes. So my x-axis, well, we only want from minus 1. And we know that it's going to be up to 9. So I'm going to change this to 10. And then on the y, minus 1. Well, we want that up to, let's say up to 500. So we can see. So here's my graph. So I can see that at 0, 0 and at 9, so let's put those points in, 0, 0. And then I have at 0, 9, 0. Okay, so these are this is the domain. So I said x is equal to 3. So this is going to be the point, my maximum. So this point here, when x is 3, so we have 3, comma, and we said it was 432. So if we label that, So this is our point, and this is our maximum volume. Which is at 432. So we found our value for x. We said the maximum value is 432, but we need to find the dimensions of the box. So if we go back to our box, so we have our x values here. So we need to substitute x is equal to 3. So the height of our box is 3 inches. So, and then we have the length and the width are the same. So we have 18 minus 2 multiplied by 3. So 18 minus 6. So that is going to be 12. So the dimensions of our box is going to be 12 by 12 by 3. And if we check that, 144 multiplied by 3 is 432.